There was on the second term seminar, I can see. The third term seminar. I'll show it. Yes. I'll give you all what you called. I already gave you a time a bit earlier, so I'll give you 2 more minutes to complete this page. And once I'm done with these questions, I'll be screenshot the next page. Huh? So I'll keep these questions for 2 more minutes to be complete. Just write the question. What do you call? Write the name as grade 11. You're in Western Province. You're in evaluation. I'll be giving the printed copies soon. Don't worry. For now, just refer this in. Those who are new will have to maintain separate writing book paper class. The questions I'll be giving you all, but yeah, maintain a separate book. Is private chat disabled? No, it is enabled. Should I share the Zoom link to my friends? Yeah, yeah, you can share. Anyone can join. Yeah, let me actually share this link for others as well publicly. When you are schooling during your class, or do you have your depends. Exactly, it's possible. Okay, then I share it. Yeah, scroll the next questions down. Alaikum salam. Yeah, start doing these questions out of here. I'll give you to complete these questions. I'll give you 2, 4, 6, 8. 1, 2, 3, 4, 5. I'll give you 10 minutes. 10 minutes is too much, but I'll give you 10 minutes. Where is my this one? Timer. Those who are done with all these questions, you can raise your hands up in Zoom. Just write the question number and your answer, okay? Which question from Roman number 3 to Roman number 8? Write the question number and the answer number in your writing book. Walaikum salam. Which question? All the questions from Roman number 3 to 8, everything. All the questions I can see. And now we're having the exam. You said you'll be giving after finish the 13th. For Kolanda, actually, I'm planning for this week. I'm still planning. Online, I'm planning for online and Velavatta, I'm most probably planning next week or this week. It'll be sudden. Don't worry. The unit test. Term test, there'll be 2 weeks before I inform. But unit test, most probably it might be for this week for Kolanda and Velavatta. I'm still planning out some stuff. Within today, I'll update you. Okay, Hussein, that's fine. This week is unit test based on third lesson. So let's see. Yeah, Abdul, yes. Semester anyone can, unit test only one. No Kajja. Will there be a semester? Yeah, semester will be there once the third lesson is over. I mean, like, if the once your exams or let's say in mid of August, you will have the semesters. I'll inform at least 2 weeks ahead, don't worry. Yes, Umar have. Is it like real exam? The real exam is semester. That will be there in mid of August. I'll inform at least 2 weeks before the date. But the unit test will be having more probably this week in the class. Closed book during class hours. Kalja, I'll keep in the academy tomorrow. We're going to the academy tomorrow. I'll keep it there. You can take on the reception. Yeah, we'll be discussing these questions. There's a time of 4 minutes remaining. Those who are done with these questions, raise your hands up in Zoom. Yeah, only to the seventh one. From Roma number 3 to 7. Once you're done, raise your hands up in Zoom and then we'll start the discussion. In online hours, it will happen. I'll explain the class, don't worry. Why August? School holidays also. Because it's school holidays, I'm going to hand August. You can come and do it properly. No more than telling the class, don't worry. No, more about the closed. Yes, Nafa. Yes, Ibrahim. If it shows for your chat is disabled, then you can click on my name or there's profile picture, that message I sent you now. And you can send a message, okay? Look, what's double WhatsApp message this number and I'll send it to you. Today I was recently seeing that status. That number always is like that. You'll have another 2 minutes remaining. Those who are done with the question, raise your hands up in Zoom. All these questions. Yeah, you can first. 'Well, I'll be discussing in a while, then you can see that time capability if you want first. Is it? 10, 9, 8, 7, 6, 5, 4, 3, 2. Okay, time is up. Let's check your answer. So this was a question I initially shared, and then only went for the other questions. So let's check this and then go for the next. Okay. The first row of the table shows some images of ports labeled from 1 to 4. The cable head connect to each of that port are given in an incorrect order in the second row under the labels A to D. Okay, in the first row they have mentioned the ports it seems. Second row they have mentioned some cables and they ask you to match the correct cable head in the match the correct port in the first row with the correct label in the second row. Write the number of the port along with the matching letter A to D of the cover of the cable head. Okay, so there are four ports here. The first port we call this port as the RJ45 port. Okay, or else you can also call this a LAN port or network port, but mainly we call this RJ45 port. The second port we call this as a VGA port. Now, some of you may be wondering, so how do you differentiate VGA and serial? Because VGA and serial almost it looks like the same. One way you could do it is if you look at the pattern of the ports, what do you call in VGA port? In VGA port, you might notice the ports are arranged like this. See, like a V shape. See, like this, like this, like this, like this, like this, like this. You might notice in a V shape only the ports are arranged. Mostly in serial ports, it's like a box. Like there'll be equal number of ports. That's how mostly serial ports come. And but this VGA port looks a bit awkward. You don't get a port like that. Anyways, the third port we have is called the HDMI port, and the fourth port we call this as a USB port, right? So out of these, if you tell me, out of A, B, C, and D, which one can you connect inside the RJ45 port? You can send me your answers to the chat. What's the correct port we connect router and printer? Okay, for exam. Um, New printers you can connect using USB port itself, but you can also connect certain old printers using the RJ45 port. So there are certain printers you can connect using RJ45. But if they have mentioned router and printer, then RJ45. In RJ45, you can connect router as well as certain printers. Like if you come to the academy physically, just go and check that printer. That printer has a RJ45 port. We have not connected the RJ45. I think we have connected using USB. You can connect using RJ45 as well. There will be port hanging. Yes, perfect. out of the three ports and out of the four ports, out of the four cables, the cable which you can connect inside the RJ45 port is going to be C. Perfect. So one has to match with C. And then VGA port, which one has to be connected to VGA port out of A, B, and C and D? Perfect. Out of A, B, C, and D, you have to connect it using the A. And then HDMI port out of A, B, C, and D, which one should you connect it to? Which one looks like HDMI cable? Correct, 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 correct. Out of all the given cables, the cable that looks like the HDMI cable is actually D. Yes, correct. No, B is actually USB. So third is D, and fourth is the USB, the remaining below. Okay. So that's a USB cable, RJ45 cable, HDMI cable, and the VGA cable. Match them together this. If you got these answers correct, put half marks each. If you have any questions, drop in the chat. If you got this correct, put half marks each. Next, consider column 1 and 2 in the following table. Write the suitable terms for A, B, C, and D from the brackets given below. Okay, let's check. It's an input device, A. So out of the given answers, which one is representing an input device? Supercomputer is a type of computer. Hybrid computer is a type of computer. Control unit, these are part of the CPU. Joystick, yes, joystick is actually the input device. So A has to be matched with joystick. The reason is because A and B, these are two types of computers. Control unit, that's a part of the CPU. Joystick is only the input device given here. Any questions? Drop in the chat. Huh? That is a marks. Fastest and the highest capacity computer in the world. So out of supercomputer and hybrid computer, what is the most fastest computer? The name of the computer itself has the answer actually. What is it? CPU is input or output? None of the above. CPU comes as a processing device. It's a device used to process data. Not input, not output. So there are four types of device. Though normally we don't take a processor as a we don't take processing as a type of device, even though CPU is what it does is processing, we don't consider it as a type. Because apart from CPU, there are no other devices which comes under that category, right? So in terms of device, we normally take input device, output device, storage device. There are three categories. You can take a category for what you call processing device as well, but we don't take it like that normally. Yes, out of the given two types of computers, supercomputer is the fastest. So B has to be matched with supercomputer. And then C controls all operations of the computer. Who controls all the operations? All operations means that is only going to tell, okay, if a data comes, okay, this data go and show in this. So for example, when you're playing a music, let's say you're playing a music using YouTube, playing that music in YouTube, YouTube will be giving two data for your phone. It will be giving an audio, it will be giving video. So your CPU is the person who's inside your CPU, there is a part called control unit. This control unit is only going to tell, okay, sound go and play using the speaker. The video which you're going to get, go and play using the monitor. I will show it using the monitor, show this using the speaker. The control unit will tell, okay, take this output and put it here. Now, if you enter something in the keyboard, the data from the keyboard to your, let's say you are typing a Microsoft Word document. You're type in that document, let's say you click on the keyboard, the control unit is the person who's going to tell, okay, take the data we typed and show it in the Microsoft Word document. So facilitating the data that's coming from the input device, that's going to the output device, all these are done by the control unit. So C is going to be matched with control unit. Again, if you have any questions, drop in the chat. Huh? Yes, I will do. But sir, it is slow in processing, right? No. Speed depends on the processor's power. So if you have a latest generation processor, it will be fast. If you have old processor, it will be slow. Computer which operates according to analog signals and digital signals. Yes, that's going to be hybrid computers. Before I finish this question, let me actually elaborate this a bit. I'll come to the marks, right? But before I come to the marks, let me actually explain that. Normally, if you take the computers, the computers, right? If you take computers, you can categorize computers or types of computers. You can categorize the types of computers based on two categories. Right? One is you can categorize based on the size. And the next one you can categorize based on the technology used by that computer. Okay. So when you say based on size, the largest size of computer we have is a supercomputer. This is the largest in size. After supercomputer, the second largest type of computer we have is something called as mainframe computer. And then the third largest computer we have is a mini computer. And the smallest type of computer we have is a micro computer. So based on the size, these are the types of computers we have. So this one is the largest in size. And this one is the smallest in size, right? And in terms of technology, you can categorize into three types. One is something called as analog computers. One is something called as digital computers. So, and the third category is something called as hybrid computers. So, in terms of difference of these three computers, if you take analog computers, it deals only with analog signals. What I mean by analog signals is, now if you take your computers, what do you call? There are certain types of devices, electronic devices that deal with like varying data only, fluctuative data. Like the data that's coming is not two different values. The data that's coming can be a varying value. Like for example, if I have a thermometer, okay, from a thermometer, the data I'm going to get, let's say a thermometer is connected to a device, okay. So if a thermometer is going to connect it to a device, always the value won't be one, like two different values, right? The value will be always a different, like there can be 1, 2, 3, 4, 5, 6. The temperature can be different values. It's not just two different values, right? But even the same thing, if you take even this as well, certain sensors, not sensors. If you take these, what do you call the heartbeat? No, heartbeat. That is digital actually. That's hybrid. If you take devices like the meteorological devices, the device that checks wind speed, the device that checks humidity, all those stuffs, the data those devices are going to deal with are always not two different values. It's always a fluctuative values. So if a device is going to deal with fluctuating, the values can change. Like temperature can change, wind speed can change. These devices we normally call them the data that we are getting from those devices. We call that data as analog signals. So analog signals might look an analog signal is a graph. Analog signal might look like this. The values of analog signals will change. The values we're getting from the device can have different values. Okay, if I tell this is 0 and this is let's say 100, it can have different values going up and down, the values can change. But on the other hand side, there's something called digital signals. Digital signal, you have just two values. Either the data is going to be 0 or the data is going to be 1. Like for example, now the data is, let's say, if you look at the graph of how a digital signal might look like, either will be like, okay, currently the data is 0 or currently data is, 0 or else 1. 1 or else 0. So if you take analog signals, it's always like two values. It's either 0 or 1. There is no change. There is no fluctuations. Like there is no 0.1, 0.5. Like that, we don't have anything. It's either 0 or either 1. Okay, the data is going to be something like this. So if you take what you called most of the computers, if you take the data, like the computer as a device, within the computer, all the communications from one device to another device, all the communication, like for example, from the keyboard, when you go and click on a key, there's a data that's being carried from the keyboard to your CPU, right? The data that's carried, from the keyboard to your CPU, right? So when you click on a key, the data that's carried from the keyboard to your CPU, it's always carried in binaries, like ones and zeros, right? So that you can see that signal is completely representing only ones and zeros, no? So if the data is going to be the data that's coming to a device, if it's going to be only ones and zeros, we call these types of data as digital signals. So your computer is made like the computers you have at your home, the laptop, the computers you have in your home, they're all dealing with only these binary values. So if a computer is going to deal only with these binary values, only with ones and zeros, only these types of signals, only digital signals, those types of computers we call as digital computers. The computers that's going to deal with only fluctuating values like this, we call them as analog computers. There are certain computers that deal with both analog as well as digital signals. Those computers we call as hybrid computers. Like for example, if you take an ECG machine. In ECG machine, it actually records your heartbeat. So that heartbeat is actually a analog signal, right? And then using that analog signal, it will actually draw a graph. It will generate. You can actually generate that strip. That is a part of a digital computer's role. Yeah, the analog signal and digital signal. There is a conversion happening. Both the data are being used. So it's a hybrid computer. You might have seen sometimes smartwatches. But there are certain smartwatches. Not a smartwatch, but there are certain smartwatches you would have seen. In those smartwatches, it can even calculate the heartbeat. Okay, so those smartwatches normally, if the smartwatch does not have that sensor, it's going to be a digital computer. But if there's a smartwatch with that heartbeat sensor, then you can see it has the smartwatch features as well. You can call in that watch. You can send messages sometime that watch. You can see your phone's notifications through that watch. So in that smartwatch will have a digital cameras feature as well as heartbeat is analog data now. So it has a analog data as well. So if a device has both these data, you can if a device is going to deal with both these data, you can call that device a hybrid computer. Okay. So your smartwatch, then ECG machine, they all come under the category of hybrid computers. So yeah, in terms of computers, these are the two types of computers, and this is how you categorize. I mean, these are two categories of computers, and under these two categories, these are the types of computers we actually have. Is that clear, all of you? This is just a summary of what that question is reflecting to. If there's any doubts, drop in the chat. Next. I don't know. Oh, no. It didn't show anything for me. Anyways, coming back to this question, if your answers are correct, put again half marks each. Half marks, half marks, half marks, and half marks. Yes. Again, if there's any doubts, drop in the chat. Okay, for the next question. Few of the computer storage devices that vary in capacity and access speed are shown in the diagram below. Okay. Write the correct storage device for the label A to D in the form given below. Okay. So they are saying from A to D, if you take the value, the capacity increases. Okay. And from D to A, the arrow is not proper, but if you look at this arrow, the speed increases. So let's check. What else has me? Okay. How to color the paper class students? Physical class students I'll be giving in the class itself. The online students I'll be giving it to you all with the fourth lesson. Still, I have not dispatched the tute. So with the fourth lesson tute, I will let you know. So once still the tutes are not dispatched. Once it's dispatched, I'll give you an update. Don't worry. For now, just refer these questions which I share and maintain a separate writing book and write the answers there. Okay. So in terms of the devices given, you can see hard disk is there, register memory is there, main memory is there, and cache memory. Let's talk about speed. That's easy. So when you talk about speed is increasing, that means A has to has a fastest in terms of speed, right? So tell me, out of hard disk, register memory, main memory, and cache memory, what is the device that's the fastest? Anyone can join. For the due to the, I'll inform later the once everything's ready because I will still get the file only the tunes are available. The files is still printing. So after I let you know. I will most probably, but once I get everything, I'll let you know. Not now. Okay, I'll give you a hint. When you take the computer, what is the main component in the computer? Like your computer, there are several devices, right? Out of all the devices, what is the main person in the computer? Like without that device, you can't even call that as a computer. Yes. The main part of the computer is actually your CPU, central processing unit. That's why you also call it as a brain of the computer. Okay, CPU is the main part of the computer. So any devices you have in the computer, right? Any device you have in the computer are going to deal with this with the CPU. Are going to deal with the CPU. So in terms of speed, normally speed means what? Speed is going to refer to the time taken to do a specific action, right? Now in the computer, if you're referring to time taken to do a specific action, that means the time taken to process the data, right? Once you go and click on something, if you want to get a response, that time taken is basically to process something. So definitely, out of all the devices, who is going to be the fastest is obviously going to be what? The CPU, right? CPU is going to be the fastest device out of all the devices. The reason is because he is the processor. He is the person who's going to mainly process the data. So obviously that person is going to be the fastest. Other all the device, if they want to process that data, they have to give that data to the CPU and CPU will process and then they get that data back to them. Okay, they can't process data if not, right? So keep in mind, CPU is the main fellow, and that fellow is the fastest. After that only comes others, right? Because that's the main thing. So out of all these devices, if you take, you call in terms of let's say taking a CPU, inside a CPU there are three people. One is the ALU, one is the CU, and one is register memory. Now in this question, they are talking about storage devices, right? So in terms of storage devices, there is one storage device inside your CPU itself. That's what we call as register memory. It will store the data that is needed for ALU to process because ALU is a person who can normally process the data. Like if there's a logical thinking to be happening, if there's any thinking to be happening, that thinking is going to be done. That calculation and thinkings, the logical parts are going to be happening by ALU. So for ALU to do that thinking, register memory is a person, register memory is going to be the object that's going to store that data. Like for example, if I ask the register, if I ask the CPU to tell me what is the answer of 2 plus 2, register memory will hold these three data. It will hold the number 2, it will hold the addition, it will hold the 2. It will hold three data. So it will hold these three data and it will send these three data to the ALU for processing. So ALU will process the data and ALU will find the answer. And ALU will be like, okay, the answer is 4. So once ALU gives the answer 4, now what will happen is register memory will forget all of these values and now it will store this value in itself. So it will store only one data. Earlier it was stored in three data. After ALU process, it will forget all the old data, it will store the new data. So ALU actually processes the data and register memory is going to hold that data that is needed for ALU or that is computed processing by ALU, right? So out of all the devices we have, ALU is only register memory is only the fastest storage device. You can store and take data from ALU. Sorry, from register memory, you can store and take data very quickly. So register is going to be the fastest. Okay. After register memory, who do you think the next fastest is? Is it hard disk? Main memory means we are talking about RAM here. Main memory, we are referring to RAM here. So out of the remaining disks, hard disk, RAM, and cache, who is the fastest? Correct. Out of these remaining devices, the fastest device we have is actually the cache memory. Okay. So cache memory only normally stores the cache memory has two main jobs actually. One of the main job of cache memory stores the data that are frequently used. Like for example, if I take this PDF, okay, this PDF is not stored in my computer. This PDF is actually stored in my Google Drive account. Okay. Even though I'm opening this currently in my computer, if you look at the URL, you can nicely see. The URL is it's not like see this one G drive, okay, my drive, ICT, blah blah blah. It's not in my computer stored, it's actually stored inside my Google Drive account. Okay. But when I open this file from my computer, I have connected my Google Drive and my laptop. Forget about how and all those stuffs. But hard disk is not inside the CPU. It's located outside the CPU. Yeah, hard disk. One person asked hard disk. I'll come to hard disk. We have hard disk, Have time, wait. What do you call yeah, coming back to what do you call the speed? If you take this file is stored in my Google Drive. And if you take the size of this file, I think this file is around, forget about this file. I have the writing book, right? This writing book is around, but I write here. This is around 99 MB. I can show you if you want here. This writing book, you can see writing book 2 kilo. Writing book 1 is 137 MB. Writing book 2, you can see in the bottom, it's taking 99.7 MB space. But when I open this file, it might open quickly. When I open this file, sometimes it will open quickly. It might not take much time. But when I'm opening this file for the first time, then it might take time. Even though first time it takes time, second, third time, it might open quickly. The reason is because this is a file that I frequently use, right? So the files I frequently use, normally what will happen is without storing them, like normally the files in use, files that are currently in use, okay? Normally the files you are currently using, now at the moment I've opened this document, no? So when I open this document at the moment, it will be there in the RAM. So all the files that currently in use, it's there in the RAM. Currently in use, it's there in the RAM. And when you're not using the file and you want to store the file permanently, the files are stored inside the hard disk or any other storage device. Now my Google Drive account is acting like a hard disk for me. Okay. So in my hard disk only, you normally permanently store it in the device. Permanently store the data. Permanently or store the data in the hard disk. And when you're using the data, it will be always taken from the hard disk to the RAM. Now in my case, what happens is my hard disk is not a local hard disk. Meaning my hard disk data is not stored in my computer. All my data are stored in my Google Drive. I have connected my Google Drive directly to the computer. So all the data I store will not be stored in my computer. Instead, it will be stored in Google Drive. Okay. So in that case, what happens is, if I'm going to always download the data from the Google Drive, whenever I open a file, the actual process, what happens is what should happen when I open a file, the actual process, what should happen is from the Google Drive, it has to take the data and it has to load that data into the RAM. Now imagine every time I refresh this PDF, now for example, let me save this PDF. And let's say every time I refresh this PDF, if it's going to take from Google Drive, load it to the RAM. Take from the Google Drive, load to the RAM. Unwantedly, there is an internet cost for me. Like for example, if I load this, you can see it's loading comparatively a bit quickly. It does, the time taken to load a 100 MB file. Okay. What happened here was it loaded quickly. You might notice it took a bit amount of time. Right? If you're not why it took that amount of time, actually, it took that amount of time because it's not taking from Google Drive and stored into the RAM. It is taking from somewhere else and stored into the RAM. If you ask me where is that somewhere else, that somewhere else is called the cache memory. So what this cache memory does is, this cache memory will store the frequently used files. The files that are frequently used, the files you opened recently, and all those stuff, the frequently used files, they're normally stored inside the cache memory. Okay. Yes, it's a Western Province third-term paper. Okay. So what do you call the frequently used files is there inside the cache memory. So what happens is when I load this file, it is not going to take from Google Drive. It is going to take from my cache memory and give it to me. That's why it's comparatively fast. So cache memory is a device that's there inside my computer. But Google Drive, it's not inside. I mean, even though I have connected, technically to take a data from Google Drive, I need internet. So depending on my internet connection, sometimes the speed can change to get the data. Okay. But from cache memory, that is not going to affect. My internet speed is not going to affect because why? Both the devices are there inside my computer. Okay. So keep in mind, whatever the data you're currently using, it will be there in the RAM. And when you're opening a file, your data can be loaded either from the cache memory or else the hard disk. So if it's the first time you're loading, obviously you'll be loading from the hard disk. But if it's like very frequently you open it and again you're going to open it, what will happen is without again reloading the data, it'll load it from the cache memory. So this cache memory is a device that's normally used to what you call store the frequently stored data. Is that clear? So out of all these devices, if you take cache memory, that person is actually working very faster than the RAM. Okay. So second is going to be the cache memory. This comes in grade 10, chapter 3. What a question. What a question. Even if you told me chapter 1, chapter 5, chapter 6, not chapter 6, I can't. But if you told chapter 1, chapter 5, even I would accept. Chapter 3. Chapter 3 is number conversion. Chapter 4 is logic gates. Does it even have a small connection with chapter 3? Actually, it's chapter 3. I was testing you know the chapter 3 actually. Because I know you cut the classes in chapter 3. It is chapter 3 last part. Chapter 3 has three sections: number conversions, coding systems, and then storage devices. It is not chapter 2. It is not chapter 2. In chapter 2, you learn the devices. You learn the name of the devices you learn in chapter 2. But you learn this storage and speed you learn in chapter 3. This is how I can misuse your absence. Anyways, when did I cut? Wait, Murshida or this is Rushda? I thought I had mistaken. I went to send a message, but I wasn't 100% sure. Hmm. I was just kidding. Man. Yes, I have disabled the main chat. That's Murshida. No, you can't. You skipped, right? So, your second one is actually the register memory. Sorry, cache memory. Yeah. Plot twist. No, you are asking so much confusion. But again, you learn about the name of this device in the first lesson, second lesson. The third lesson, you learn about the speed and the storage. C. What is C? Yes. Correct, 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 correct. Only one wrong answer I got for now. Interesting. Will there be, I think, an answer? Two wrong answers for now. 1% change the answer. You can ask now, it's in Hollywood. Yes, correct. Okay. So, what do you call the third fastest device? Your RAM. Okay. And the last device basically going to be the hard disk. Hard disk is the slowest out of the device given below, right? The best example I can tell you is if you're comparing RAM and hard disk, okay? RAM is stored in the devices that's currently in use, okay? Tell me, your phone, you have this background running applications, right? Your phone, you have the background running applications, right? To open a background running application, you can open that quickly, or to go to your open application newly. Like to open application newly, does it take time? Or to open the background application, which is fast. What I mean by background running applications is if you have like a phone, if it's an Android phone, on the left side you have three lines: the home button, the back button, and you might have three lines if it's Android phone. If it's iPhone, if you long drag long by this, you can see the background running apps, right? So these background running applications, okay. What I mean is this fellow. When you have the phone, you have these like background running applications like this off the blur. Like if you like drag the sun from down like this, you can see that the backgrounding application like this, right? So these backgrounding applications, what I mean, these backgrounding applications, what do you call they are always stored in the RAM. So you can open that tab quickly, or open a brand new app quickly. It's there in the YouTube file. Let's check that. Exactly. The background app you can open actually quickly. So the background apps are all mostly served from the RAM. And what do you call the newly opening app? That the app should get the data from the hard disk to the RAM. So getting the data from the hard disk to the RAM takes time. That's why sometimes to open app newly it might take time, but open the app which is in the background, it can open quickly. Okay. So RAM serves the data quickly compared to hard disk. Then ask at the end of the class. Correct. So that's how you actually remember. If you know the purpose of how these each of these storage device works, you can easily figure it out. Two I have it. I'll let you know about that update later. I think the phone background app is not cleared for decades. I actually recently cleared, and after I clearly you have so much. I don't normally clear it. Boring to clear. Okay, so yeah, if you mention that A is register memory, put half marks. B is cache memory, half marks. C is RAM, half marks. D is hard disk, half marks. Huh? If there's any other doubts, drop in the chat. Yes. Any questions, drop in the chat. Doesn't battery be used for that? For one operating system, it works in different ways. Steve Jobs has done a very good job making sure he focus on the efficiency in that. Or the phone gets stuck if so many apps are open. Android phones, yes. In iOS, it doesn't happen. Next. Calculate blah 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 base 2 plus blah 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 base 8 and represent the answer in decimal. First of all, tell me the first number given. What type of number is this? So they are asking you to add these two numbers and show the answer in decimal. No? But decimal is one type of number system. But the first number given here, what type of number system is this in? Not exactly. It wasn't earlier, but now yes. You seem to be right in every argument. Binary. Correct. Exactly. Oh, it's a binary number. So normally if you take a number, by looking at the number, you can tell what type of number it is, right? So there are, for your syllabus, you have learned a couple of types of numbers. Let me explain. I'll be showing in a while who's right. Here you go. Yeah. So normally when you look at a number, for example, if you look at a number like this, but if I write, not look at, forget about numbers. If I write a letter, for example, if I write something like this, you know, you can look at this and tell, okay, this is a singular word. Or if I write something like this, okay, you can look at this and tell basically it's a Tamil word. Forget about my spellings. Or if I write like something like this, you can look at this and tell it's what you called English. Okay. Or if I write in different language, just by looking at it, you can actually tell what you called. Sorry, it's not this should be just okay. You can just look at it and you can be able to what do you called I can even write in Arabic here. I just wrote three examples for a moment. Okay. More than seen later. Right? You can just look at these three and you can easily figure out it's actually Sinhala, Tamil, and English word, right? Now, when you take what you called numbers as well, okay, when you take numbers as well, just by what you called looking at the number, you should be able to identify what type of number is it. So just like we have different alphabets, like we have different languages like English, Sinhala, Tamil. Even in numbers, there are different types of numbers. One type of number is called a binary number. One type of number is called a decimal number. One type of number is called an octal number. And one type of number is called a hexadecimal number. Just like we have different languages called English, Sinhala, Tamil. In numbers, there are different types of numbers called binary, decimal, octal, and hexadecimal. So if you're wondering how did this origin, how was this created? Technically, out of all these, decimal is the main fellow. This is the number system that's mainly used by humans for our day-to-day communications. So when you are when you're like, if I come and ask you how many students are present, how many students are absent, what's the marks you got, Every communication we're going to have between humans, we always have in decimal numbers. But if they take computers, the computer is mainly electronic device, which can deal with mostly two signals, either on or else off. So the whole computer is actually, even though there are lots of things that the computer does, the whole core component of how a computer works is it's like owning and offing stuffs. So normally in the computer, on is represented using 1 and off is represented using 0. So using 1 and 0, they formed a language called a machine language, right? So your whole computer, inside your whole computer, every component, like let's say your keyboard and your CPU and the monitor, all the components, all the things inside your computer, they are all communicated using something called machine language, or else you can call these ones and zeros as binaries. These are called binary numbers. Okay. So if you take your computers, within your computer, the communication always happens using binaries. So if you take binary, this is normally used within the computer to communicate between devices. Like for example, your CPU and your keyboard and CPU, both of them are going to communicate using binary numbers. And if you take two humans, both of them are going to communicate using decimal. Now you might be wondering, then who the hell is octal and hexadecimal? Octal and hexadecimals are number systems that are not actually real number system, but they were made to make our work easy. I'll explain you how. Back then, they used to write machine language. This machine language, I said there's a language which we created using ones and zero. No. Back then, people use when they want to store this, what do you call, when they're going to create programs, when they're going to create applications, when they're going to create softwares, they used to write the programs using machine language. They used to write it on papers. So when they were writing sometimes binary numbers, sometimes the binary number might be too long. Like for example, imagine you want to represent a binary number like this. The value of this number can be very small. Okay, if I convert this number decimal, it might be a small number. But I mean, the number of digits might be less. But in binary, you can see the number of digits high. So sometimes when writing these binary codes, they were like, okay, the number of digits are too much. Can't we shorten it? So what did they do is they were like, okay, let's shorten the binary number and write. So when they were writing the binary codes, when they had to like the code which they used to create computer programs, uh, those codes when they want to store it, they used to write it on paper. No? So when they want to simplify the writing without having a long number, when they want to shorten this number, they were like, okay, let's do something like this. Like for example, you all have this habit, right? When you want to type I don't know, without typing I don't know, you might go and type IDK. You know what is the meaning of IDK. Like for example, likewise, you all have these abbreviations, right? Just like you all have created these one abbreviations, they were like, okay, let's do something like that. Killer. What they did is they group this whole number into 3 digits by 3 digits, where these 3 digits represented 1 digit. These 3 digits represent 1 digit. These 3 digits represent 1 digit. So the grouping that is done by grouping 3 bits by 3 bits, 3 bits is going to represent 1 digit. These 3 bits are representing 1 digit. These 3 bits are representing 1 digit. So for example, the word bit means a binary digit. Huh? The word, if I say use the word bit, what I mean here is one binary digit. So for example, if you had a number that had 12 bits or 12 binary digits, once you convert this, like group them into 3 bits by 3 bits, you will have 4 digits here, right? You take by 3 bits by 3 bits, there'll be 4 different digits. Like each digit is going to represent 3 bits, right? So the number that was formed by grouping the what do you call binary number to 3 bits by 3 bits, that is what we call as octal number system. So another name for octal number system is a 3-bit number system. The reason we call it a 3-bit number system is because we take the whole binary number and group it into 3 bits representing 1 digit. 3-bit representing 1 digit. On the other hand side, there was something called hexadecimal number that was created. This was done later on. They were like 3 bits is not enough. Let's make it some more shortened. And without mentioning, like for example, there are people, uh, you know, for okay, the word okay, they shortened it as okay. And some now they shorten it some more and they use the word called K, right? Like when you want to represent, when you want to say the word, the original word, okay is the correct word. Okay. But when you want to shorten okay, you'll be like, okay, it's shortened like this first. And now we have shortened okay to be something like this, right? Likewise, earlier they had this 3 bits by 3 bits short. And they were like, let's simplify some more killer. After that, they create another number system where without grouping into 3 bits by 3 bits, they grouped into 4 bits by 4 bits. So if you have a binary number like this, they were like, okay, these 4 bits are representing 1 digit. These 4 bits are representing 1 digit. These 4 bits are representing 1 digit. So by grouping the whole number into 4 bits by 4 bits, the number system that was made is what we call as a hexadecimal number system. So these are the number systems that actually have, and this is the history behind this number system. Okay. Anyways, where is my point? Yeah. So in that case, what happens is you can look at a number, just like you can look at these number, what you call letters, and you can look at Sinhala, English, and Tamil words. Even by looking at certain numbers, you can tell. Normally, if a number is written as it is, there is nothing you can see apart from the digits. If there's nothing else you can see, then definitely this number is going to be a decimal number. But there are ways you can identify a binary number. How a binary number will be written is it will always have, after the end of the numbers, it will always have the base 2. So in binary, the base is 2, decimal base is 10, octal base is 8, hexadecimal base is 16. So always you can identify what the number is using the base. Okay. So if a number is written in front of that number, if the base is written as 2, then definitely it is a binary number. If there's a number written like this, and if it's written as base 8, then it's definitely octal number. Okay. And if it's a number like this, for example, with base 16, then definitely it's going to be a hexadecimal number. So looking at the base, you can easily tell, is it decimal, binary, octal, or hexadecimal. Okay. Anyways, this is basically how to identify a number. I'm not going to explain much detail apart from this. Okay. So in this question, they're asking to add this binary number. The second number, you can see base 8. So base 8 means that's going to represent a octal number. So they are asking to add these two numbers and give the answer in decimal. So the first number we have is 110011. Let me take that number 110011. And that's a base 2 number. The second number is 72 base 8. Right. And what we're supposed to do is we're supposed to add these two numbers and find the answer. Right. Now, when you're adding these two numbers, for example, if I ask you to what do you call you know, if I give you a, let's say, two different words, and if I ask you to form a sentence, right, you'll always make sure that both of the words are in the same language, right? Only if both of them are in the same language, you can form a proper sentence. If you're going to use two different words and one word from one language, give me a moment. Sorry. What do you call? So if you want, what do you call? If you want to add these numbers, you want to make sure that all these numbers are in the same base, right? So the answer they want in the decimal they have mentioned. So therefore, the easiest is convert everything to decimal. So I'm going to convert both of these numbers to decimal, right? I'm going to convert both of them into decimal. So the process of converting is like this. I have a binary number from any number system. When you want to convert decimal, the process is the same. What you should do is multiply each digit by its place value. Multiply each digit by its place value. So for example, if you have a number like this called 111011, to convert this to decimal, I said you have to multiply each digit by its place value. So this place value is something like when you were doing your grade 2 or grade 3, you would have learned, right? This is called ones place. This is called tens place, hundreds place. That is what you call it, place value. Okay. So from number system, the place value changes. You can derive the place value using two data. One is you should know the base and the position. So for example, always the position is constant. The position is going to be 0, 1, 2, 3, 4, 5. The position is constant. The base will change from number system to number system. So you can see this is a binary number. So base is 2. No? So you can find the place value of this digit by taking 2 to the power 0. This is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, and 2 to the power 5. Okay. By that, you can find the place value of each of these digits. So the place value of the right side column digit is 2 to the power 0. That's equal to 1. 2 to the power 1, 2. 2 to the power 2, 4. 2 to the power 3, 8. 2 to the power 4, 16. 2 to the power 5, 32. Once you find the place value of every digit, So this is talking about the place value of every digit. Once you have found the place value of every digit, just multiply each digit by its place value. So 1 times 32 is 32. 16 times 1 is 16. 8 times 0 is 0. 4 times 0 is 0. 2 times 1 is 2. 1 times 1 is 1. Once you have found multiplied every digit by its place value, now you are supposed to add them together. So once you add them together, that will be basically 32 plus 16 plus 2 plus 1. I ignore the 0 because 0 doesn't have value, no? So 32 plus 16 is 48, 49, 50, 51. So once I convert this decimal, the answer is going to be equal to 51. If I follow the same approach and convert, 72 base 8. 72 is actually a octal number. So to get the place value, you'll take octal's base, that is base 8, position 0. Base 8, position 1. Always position start with 0, and towards the left-hand side, it increases 1, 2, 3, 4, 5. So 8 to the power 0 is 1. 8 to the power 1 is 8. Then you multiply each digit by its place value. 1 times 2 is 2. 7 times 8 is 49, 56. Once you have multiplied each digit by its place value, now you're supposed to add them together. So that's basically equal to 56 plus 2. That's 58. So once you convert 72 base 8 to decimal, you get the answer 58. Now it's very easy. You're supposed to add them together. 52 plus 17 is equal to 52 plus 58 is equal to 110. The answer is 110. This is how we do the question. Anyone having any doubts here? You made a mistake. What is the mistake I made? 51 and 58. Sorry, 59 plus 58 is not 52. By mistakenly, I wrote 52 here. It's not, it should be 51 here. Sorry, my bad. This should be 51, not 52. Then writing, I wrote 52 there. So 51 plus 59, 58, that's going to be 109. Sorry. So answer you get there is 109. Thank you for the correction. Any other doubts, anyone? Yes, YouTube has all the number conversions properly. Here I just showed quickly, but I wrote the question. Yes. Do we need to show all these methods? Yes. Anyone having any other doubts? Should we put the base? Decimal numbers, actually base is not important. Whether you put the base or don't put the base. For decimal numbers, only for decimal numbers you're allowed. So for decimal numbers, if we don't put the base, it's not a problem. Should we mention the base 10? Not compulsory. Yeah, my bad. While writing the answer for this, is it right? If you write it without the base, fine. If you wrote with the base, also fine. Both are correct. How the marks are distributed? Perfect. Let me now give you the marks. Which one is the answer? Answer is 109. So how you get the marks is like this. Give me a moment. If there is anything, I'll do it. How you get the answer is for showing this method and getting the answer 58. Okay, you got this method and answer both. If you got it correct, you get half marks here. Suppose let's say you did the method correctly, but there was an issue in addition. You did not get 58. Without getting 58 here, let's say you wrote by mistake 59. Still, you will get the half marks. So your half marks is basically whether this answer is correct, okay, whether this answer is correct or wrong, that doesn't matter. If this method is correct, you get half marks there. Then, same thing for here as well. For your method, if your method is correct and your answer is correct, then perfect, you can give half marks. But let's say you got the method all correct. When adding, you did an additional mistake. Like without mentioning, when you're adding 32 plus 16 plus 2 plus 1, let's say you made a small mathematical error. Then I got half marks. I converted to binary and added. That's why I said either you have to have the method like this, or any other method is fine. You have to get this answer somehow. So if you got that, it's equal to 58, you're good to go. You can do in different methods as well. I'm saying if you do it like this, with the method expected. If you go to octal to binary decimal, unwanted, no. You can catch from here to here. Why do you want to go from there? So if you got it like this, you get the marks like this. And then for getting the answers 101, 1 mark. So if you all wrote the answer without the method, you get only 1 mark. Because the question did not specify method is required. If the question specified method is required, then you will not get this 1 mark without the method. This question has not specified, so they give marks if you directly wrote. No, I can it. Anyways, based on what I wrote here, if you have any questions, drop in the chat. But this is how the marks are broken down. This is the part two first question, right? Yes, part two first question always has mixed question. The first question has questions from multiple lessons. Okay, Roman number 5. What is it, Mushta? I had a correct. There is no order. You can write convert the binary first, or you can convert the octal first. Either one of the conversion has to be done first. Once you do either one of the conversion, then add them together. Simple. Technically, you have to find what is the value of this in binary decimal. Find the value of this in decimal. So finding the value of this in decimal half marks. Find the value of this in decimal half marks. Finding the final value 1 mark. Both Mushta. I'll come to that later. They are asking for the steps on this question. Where? They are. Wait, they are asking the steps. Sorry, I did not notice this. Because they are asking the steps, if you directly wrote 109 without the method, then 0 marks. Huh? Sorry. If you wrote 109 without the method, 0 marks. Next. Consider the logical circuit is input A and B and output is C. Write the Boolean expression for the output. Okay, so when they ask you to write the Boolean for the output, you have to first of all go gate by gate. Before we go gate by gate, let's identify the gates. Tell me what is the name of this gate? What is the name of that gate I have marked there? Again, if it is showing the chat is disabled, then what do you call? Click on my name or profile picture in this message, and you can start messaging me. Yes, correct. You can see in this, it looks like there's an AND gate, but in front of the AND gate, there's a circle. So in front of the AND gate, if you see a circle, there's a special name for this gate. No, Hasra, 0 marks. What do you call the special name for this gate? We call this gate as a NAND gate. Okay. Correct. We call this as an AND gate. And what is the name of this gate? These two actually say same. This gate and this gate, they look the same. So what is the name of that gate? The triangle and a circle in front. Correct. Perfect. Yes. When you have a triangle and a circle in front, we call this gate as a NOT gate. Correct. Yes, this is called the NOT gate. And this is called the AND gate. And this is called the OR gate. If there's any of you all who are not familiar with these gates, I have actually, in the grade 10 class, we did a summary. I'll just share a picture of this in the paper class. What do you call where is it? Yeah, I'll share a picture of the summary in the paper class community. Then you can identify the gates all easily. If there's any of you who is not in the paper class community, I'll just share the link in the chat. the link from here. Yeah. If you're not there in the paper class community, you can click on the link and join. I'll share that logic gate summary there. More WhatsApp. Okay. So let me explain. Now, depending on the gate that's being used, the output can be different. Okay. So normally to write the output, first of all, you should know the input. If you look at this gate we have here, the NAND gate, the inputs that's coming is one is A and one is B. So always, first of all, write all the inputs that's coming with a small space. And then in between that input, you have to draw the symbol to represent that gate. You can represent NAND gate by what we should do is between your inputs, put a dot, and above the whole input, put a dash. So dot in between and a dash for the whole thing. You read this as A dot B whole thing dash. Okay. So that is how you represent NAND gate. Then NOT gate is, if you take this NOT gate, the input that's coming for this NOT gate, okay, the input that's coming for this NOT gate, it's coming from here, jumping from here and going like this. So you can see the NOT gate is getting the input as A. So first of all, write the input and then do your respective symbolizing. So for NOT gate, what we do is we add a dash in front of the input. Okay. So always keep in mind, NOT gate, what you do is we add a dash above the input. AND gate, what we do is we add a dot in between the input. OR gate, what we do is we write a plus in between the input. NAND gate, what we do is we put the dot as well as the dash. And if it NOR gate, what will happen is we use a plus as well as the dash. See how for each and each gate it will work. Okay, so for example, if I take this, if I take the next one, the next input we have here, this next input is coming. Next, the NOT gates, the input is coming from B. So first of all, you write the output. Above the output, mention dash, because that's how you represent NOT gate. Now let's go for the next gate. The next gate we have is AND gate. For this AND gate, the input that's coming from the top is A dash. So first of all, I write A dash. The input that's coming from the bottom is B dash. So I write B dash. Then I told you for AND gate, what we do is in between the input, we add the dot. So A dash is one input, B dash is one input. In between these two inputs, I'm representing the dot. Okay. Now I go for the next gate. That is this gate. So this gate we call as OR gate, right? For this OR gate, the input that's coming from the top is what? A dot B whole thing dash. The input that's coming from the bottom is what? A dash dot B dash. Okay. So when you take a gate, what you do is after you write the inputs, okay, after you mention the inputs, you always see does our input have only one letter or one character or multiple characters. When I say the word character, I'm representing the word letter, okay? So if your input has only one letter, you can write the input as it is. Now you can see here and here and here and here. I just wrote the input. I told you first of all write the inputs. So when I told you write the first of all the inputs and then write the symbols, I just wrote this input as it is. But for this part, I'm going to do a small modification. This is one input and this is another input. Because both of my input has more than one character, which means because both of my input has more than one letter, for each of these inputs, I should add a bracket. So for this, I add a bracket like this. And for this, I add a bracket like this. So the first bracket is representing the first input that's coming from the top. The second bracket is representing the second input coming from the bottom. So always keep in mind, writing Boolean expressions, first step, write the inputs. Like for example, if I look at that first NAND gate we have there, the NAND gate looks like this. The input from the top is what? A. Input from the bottom is what? B. So because both of these input has only one character, I kept it as it is. And between I wrote the symbols. But if you take the green color one, which I wrote here, in the both input that's coming from top and bottom, it has more than one character. That is why I wrote the brackets. Now what you do is, in between the inputs, you write the symbols. For OR gate, the symbol is plus. So between both the inputs, I'm going to draw the plus symbol. So this is how we represent the output of C. Is that clear, all of you? So C is equal to this. We can directly write the Boolean expression, right? Yes. So here you can directly write the Boolean expression. If you wrote this with the brackets, with the symbolings all correct, you wrote it exactly, it should be exactly, there can be one difference. If you wrote it exactly like this, you get 2 marks. Anyone having any questions here? Without brackets, 0 marks. Do we need to write C equals? Not compulsory. Not compulsory. Yes, can must. But avoid that. Let me know your question in the chat. Those are any questions. I didn't put C equals. That's fine. If no bracket, 0 marks. If the line of A touches the B instead of going around, will will A connect with B in B's path? The line of A touches with B instead of going around, will A connect? That is, if that is done, it's a printing mistake technically. Because the correct way of drawing is to take this curve. To do this curve, it's proper. So without that, if they have done, that means they're representing here only. Why didn't you put a full dash in the second input? Why should I put a full dash? It's AND gate, no. AND gate, we put only dot, no. I had A dash as one input, B dash as another input. In between both of my input, I put a dot. For AND gate, we put a dot inside in between both the inputs. And a full dash for the first input, because first input was what? An AND gate. For NAND gate, what is it? Dot and dash both. This is AND gate and this is NAND gate. Two different gates. This is a NAND gate, this is AND gate. Depending on the gate, the symbols will vary. Without putting a curve, if they put a straight line, should we include B also? No, A. It's a printing mistake if they don't include that curve. Probably. If you do something like that, they should do it like this. A dot B whole thing dash plus A dash dot B dash. If you're using the dash like that, then that's how it should be. Exactly like this. Dot is to multiply. No. There is no addition, subtraction, multiplication, division, logic gates. Logic gates is about logics. What about calculations? There are three types of operations. One is arithmetic operation. Arithmetic operation is where you have addition, subtraction, multiplication, division. The second type of operation is conditional operation. Conditional operation is where you compare two values. Is something greater, is something less, is something equal. The third type of logic is called uh, operations. Logical operations where you have and or and not. These are called logical operation. There is no addition, subtraction, multiplication, division. If it's addition, subtraction, that's called arithmetic logics. Arithmetic operation, sorry. For the second one, where the A dot B whole thing dashes gets added to, can we write it as A dot B whole thing dash? Because it's common for both. No, it's not. Can't. Again, I told you, what is the input for this AND gate? For this AND gate, the input is A dash. What is the input for the from bottom? It's B dash. AND gate, what do you do? In between the inputs, we put dot. First of all, you take the input separately. In between the inputs, you put the symbol. If you put A dot B whole thing dash, it's not AND gate no, it's NAND gate no. It's two different gates. Is AND gate and NAND gate equal? No, right? It's the opposite. How can you convert 978 octal? 978, you don't 978 is not an octal number. You can't have an octal number like this. Octal numbers can be only between 0 to 7. How can you have 9 and 8 in octal number? The largest octal digit is 7. Why do we need to use these logical operations? Go and learn the programming lesson. In programming lesson, there's topical operators. If A dot B whole thing passes through another NOT gate, when the dash gets cancelled, only if both the dashes are equal in size. Exactly equal in size. Okay. Next, consider the following tools labeled 1 to 8 related to mail merge in a word processing software. Some of the functions performed by the above tools are labeled from P to S in the table below. Write down the icon number that matches P to S. Okay. So in mail merge, Microsoft Word has a feature called mail merge where you can, for example, let's say you're going to send an invitation card to multiple people. And for every people, without making the invitation card one by one, what you can do is you can make one card. And if you have a list of names, you can automatically, generate those cards. Like for example, let's say I have a template. Let's say I make one card with a person called hi, and let's say in front of is a name, and let's say I have a message here. Now let's say I have five people I have to write the invitation card for. So without going and making five different cards with the five different names one by one separated, what I can do is in Microsoft Word, there's a feature called Mail Merge, where you can actually have a list containing all these names, and you can just make one letter only. So we call this one letter as a template letter. And after you make one letter, you can automatically generate these five. For the five people, you can generate five letters automatically using this feature called mail merge. Okay, I'm not going to show that because it requires time. Let's stay in the grade 10, lesson number 6. So do mail merge. These are the what you call tools we have. This is not relevant to mail merge. And yeah, only that is not relevant to mail. That's not relevant to mail merge. To start mail merge, what is the tool you all wrote? 1, 2, 3, 4, 5, 6. Any invitation. In Word, there's an option called mailing. Like I'll open show you. You can find this in, if you go to Microsoft Word, there's a place called mailing. You'll find it there. Here, can I see a part called mailing here? When you go and click on that mailing, you'll find the mail merge part where you'll find the mail merge there. See, start mail merge is there. Okay. So start mail merge, the things we have is, the tool we have is what? Correct. It's a tool number 2. It's not there in the book. It is there in the book. I even thought that in the class. We did several stuffs there. That if I'm going to do it practical now, it take time, so I'm going to do it. Yes, it's going to be the tool number 2. Okay. So using tool number 2, you can start the mail merge. What time is the class and what is the time? Oh, it's 6:15. I didn't notice. There's one more question. We'll wait. And select the recipients. To select the recipients, what are the tool we have? Yeah, to select the recipients, actually the tool is tool number 3. You can see here. I'll show you. Okay, you can see here. To select the recipients, we have the tool number 3. I hope you all can see and I'm sharing. Am I sharing the full screen, right? Yeah, I'm sharing full screen. Okay. So that's going to be tool number 3. And address block. What's the address block? Actually, you'll be getting the address block after you select a recipient. You can't see address block by default. I'll show you if I want to. You can see these are not these are not clickable at the moment. But if I select a list, you can see that. So now you can select a list. Okay. So address block will normally tell you uh, how do you want to Wait, if I'm going to explain this, I'm going to take time. So I'm not going to tell you. Just look at the tools. Okay. So this address block. It is actually the tool number 5. And then preview result. Wait, I misunderstood this as a grammar tool. No, these are the spelling sign grammar tool. This is how the preview result looks like. Sorry. I initially thought this as a grammar tool, but yeah, that's the preview result tool. So that's going to be 8. If I'm not wrong. Yes. Yeah, my bad. That's not spelling check grammar. It's the preview results tool. I can show you a quick demo if you all want of how mail merging work. Currently, I have only one page in this document. I'm going to write here something called hi. Let's increase the font size so you can see. And let's say in front of hi, I want a person's name. So I'm going to click on this select recipients. I already have a list. I'll just take a list I have in my computer. And then insert merge field. That's easy. So in my list, I had 2 columns. I'm not showing you how to create a list because I don't have time. I'm going to click on first name here. In front of first name, keep a space. And delete son of. And mailing, insert, merge field, last name. So in my, I here click on select recipients and select a list. So in that list, I had 2 columns, first name and last name. Now what I'm going to do is I'll be like preview results. Hi human, son of version 1. My list had only one. Did my list have only one person? Or it had many. Let me, what do you call show of everyone? So in finish and merge is option called um, all record. Okay, so now I have generated the Word document now. I only created one template at hi first name, and this is how it was there here. I created something like this hi and sorry, first name, son of last name. After I created this template, I clicked on finish and merge, and I clicked on edit individual document. Then I got this automatically generated. So if you're wondering from where is human, Amal, Bimal, Chamal came, that was from a list I had in my computer already saved. So it took that list, in that list, whatever names was there, from that name, it generated. That's simply how mail merge work. I'm not going to talk much about that because that's a broad topic. But simply that's what mail merge does. So yeah, if you mention 2, 3, 5, 8, put half marks each. And total 2 marks there. What if you get 1.5 marks? Should we round off to? No. 1.5 is 1.5. If there are any questions, drop in the chat. I'm checking the chat and replying. Next. Rounding off to increase. Exactly. Consider the functions of the computer. Select and write the relevant utility software for the above task on the list below. Label the functions from W to Z to the correct one. Okay. Checking for errors in the hardware. So that is done by someone called as a disk scanner. Organize the hard disk by rearranging clusters of blah 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 defragmentation. Disk defragmentation. This is called direct. What they have done here is they are given the definition and they're asking what are they defining here simply. Protecting the computer by identifying and eliminating malicious software. That's the antivirus software. So malicious software means dangerous software or harmful software. So harmful softwares are removed from your computer using the antivirus softwares. And then temporary storage of data files for cut and copy and paste operation. It's called a clipboard. Like I can show you the clipboard of my laptop. Like for example, if I go for my clipboard, in laptops, you can get the clipboard. by pressing the Windows key and the V key. There's a Windows key and V key. This is the Windows. This is the Windows key and the letter V. So if I press Windows and V together, okay, I'll be getting my clipboard. So you can see my clipboard here. Windows V. See my clipboard. You can see all the things I copied earlier is shown here. The recently what are things I copied are visible here. All my recent copied stuffs. Okay. There's a limit for the number of data you can store in the clipboard, but the frequently stored first few will be there. Enable it. So it will get erased after a couple of time period, but yeah. No, fourth one is edit the recipient. Like you have a list, you can edit that list. It will not happen mostly. I use Windows 11. That's how a separate section for emojis there. Yeah, I am using Windows 11. What is Task Manager then? Task Manager is what you have in the bottom. You go for your computer in the bottom from this task bar. You can right click here and you can get Task Manager. So Task Manager will show you something like the device performance, the what you call background running applications, the app history, all those stuffs. So details about your hardwares and details about the softwares running, details about those stuffs you can see in the Task Manager. Need the Task Manager. Got it? Okay. Based on that, tell me. Put half marks each and tell me. Uh, half marks for this. Half marks for this. Half marks for this. And half marks for this. Out of 14 marks, I think you had 14 marks. These are the part two questions. So these are from the Roman number 3 to 7. And then we have the 1 and 2 here. So out of all these questions which we discussed today, I think it's 14 marks worth of questions. How many marks do you all get? That basically like app settings in phone. Task manager. Not exactly. Okay, so for today we're going to cover only that much. The remaining question we discuss next week. Those are any question you can still ask. Reminder: there is a seminar tomorrow. I have shared the details in the paper class community as well. A blue color poster. I'll reshare it today as well. So you can just look at it. Good, 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 good. Do you have any questions or can still ask? I can leave it until the day. Sorry, there was network issue. You ask how the dashes get cancelled, no? So it works like this. Now, if you have something like this, A dash dot B dash and whole thing dash, look at both the dashes and tell me, are both the dashes here same in size? We have two dashes, right? Actually, three dashes are there here. Are they same in size? Exactly. No. So you can't cancel it. But look at this. A dot B, whole thing dash and dash. So are these two in same in size? Yes. So if they are in same in size, then you can cancel this and just write as A dot B. But cancelling is not there in your syllabus. So if you don't cancel, it's not a problem because these are called Boolean algebraic simplification. Did I ask you to join the grade 10 seminar? I am doing two different seminars. So grade 10s can join grade 10s, grade 11s can join grade 11. Why do you want to join the grade 10 seminar, man? Anyways, there is no purpose. It's completely worthless to join a grade 10 because what is tested in grade 11 and grade 10 is completely different. Grade 10 first time is very easy. Out of what will come, what I'll be doing in the grade 10 first term, what I'll be doing in the grade 10 second term seminar, maximum you can get 5 to 10 marks knowledge for grade 11. Whatever is relevant for grade 11, I'll be covering in the grade 11 itself. So join only the grade 11. Don't join the grade 10. Anyways, Shwal, you got the point of the simplification. There is a law for this in A levels you'll be learning. I think it's called identity law, if I'm not wrong. You'll be learning this in A levels. No, identity law, I mean, identity law, idempotent law, and it's called, I can't remember the name of that law, but there is a law which tells that this is like this. Anyone having any other questions? Is there any questions? Drop your question in the chat. Welcome. I dropped your text asking about that. I replied, I mean, last week there was no worksheet discussion. Then what do you want? We did in the class. You did the worksheet in the class. We didn't have a discussion in the class. I didn't discuss it. I said I'll discuss it next week, Thursday's class. It is basically coming Thursday, I'll be discussing it. And worksheet 12 did not have a discussion. Worksheet 13 only I said I'll discuss in upcoming class. That is there in the section. That is a part of the tute. It is not worksheet. WhatsApp me this. If you have WhatsApp already, I'll check it. I'll WhatsApp the record. Any other questions, anyone? Okay, so as there's no other questions, I'm going to wind up. If there's anything, you can get back to me, WhatsApp, and I'll clarify it for you.